How does tidal energy harness ocean currents predictably? Imagine the ocean's surface moving in a steady, rhythmic dance that repeats every day and month. This natural movement is driven by the gravitational pull of the moon and the sun, combined with Earth's rotation. These forces create predictable tides and ocean currents that flow in specific directions and speeds. Because these patterns are so regular, they can be forecasted with high accuracy, making tidal energy a reliable source of renewable power. Tidal energy captures the kinetic energy of these ocean currents by placing specially designed turbines in areas where water flows fast and consistently. These turbines are similar to underwater windmills, with blades that spin as water rushes past them. When the blades turn, they generate mechanical energy that is converted into electricity. The speed of the water flow and the size of the turbine blades determine how much energy can be produced. Since water is much denser than air, even moderate currents can produce a lot of power. There are different types of turbines used for tidal energy. Horizontal axis turbines are like wind turbines but are submerged underwater. Vertical axis turbines are another option, and some devices use oscillating foils that move back and forth with the water flow. These turbines can be mounted on the seabed using piles or floating platforms anchored in place. Multiple turbines are often installed together in arrays to increase the total amount of energy generated. The predictability of tidal energy comes from the astronomical forces that control tides. These forces follow well-understood cycles, which means energy production can be planned around the timing and strength of tidal flows. This makes tidal energy more dependable than wind or solar power, which depend on weather conditions. Power grids can integrate tidal energy more easily because it provides a steady and predictable flow of electricity. From an environmental point of view, tidal energy is a sustainable practice because it uses a natural, renewable resource, the ocean's movements, without releasing greenhouse gases. It requires less space and has a smaller ecological footprint than large dams or reservoirs. When carefully sited and designed, tidal energy systems can have minimal impact on marine life and ecosystems. Coastal communities benefit by reducing their reliance on fossil fuels and gaining a stable source of clean energy. In summary, tidal energy harnesses ocean currents predictably by capturing the consistent, cyclical movement of water using underwater turbines placed in areas with high flow speeds. This process transforms natural ocean motion into renewable electricity with minimal environmental disruption, making it a promising option for sustainable energy solutions.